Well, pre-calculus classes, good morning, good afternoon, or good evening. We're going to go ahead and start into the next portion of P7. Should be a little bit shorter than the day 1, and then when we get to day 3, that'll even be the shortest of all. So, in P7 day 2, we're going to look at solving both polynomials and radical equations. For polynomials, meaning something that is above a quadratic. I mean, when it's quadratic, you can just use factoring, quadratic formula, completing the square. But we're going to talk more about, okay, what do you do if the power is bigger than 2? Now, the first thing that example 1 is actually even geared as to show you the first thing that you cannot do. Do not ever cancel variables, meaning don't say, oh, on this I can divide by x squared. If you do that, you lose solution. So what you actually have to do, move the 48x squared over by subtracting it, and then we will factor. So take out 3x squared as your GCF, leaving x squared minus 16. Now we can factor this into x plus and minus 4 as a difference of squares. So x is 4, x is negative 4, and then for this, one of the things, I don't know that we have specifically talked about this. If you're not sure about what these answers are going to automatically give you, whenever you have factors, you're just setting them equal to 0. That's the zero product property. So if you have 3x squared equals 0, divide by 3, and then x squared equals 0. So x is 0 because you would, in theory, take the square root. So you do end up with 3 answers of 0, 4, and negative 4. So that's one form of a polynomial. Example 2, where you have x cubed minus 3x squared minus 3x plus 9 equals 0. Certainly when you have 4 terms, you can always look at, is there a GCF? No, there's nothing we can divide out of all 4. So what we'll do when you have 4 terms, usually that is a grouping situation. So out of the first group, I can factor out x squared. Out of the second group, negative 3. And I end up with x minus 3 and x squared minus 3. So the first answer, we can certainly just say x is 3. Now, to get the other 2 solutions, kind of like what I actually did up here using zero product property, set this factor equal to 0, add the 3, and then when we take the square root, x equals plus or minus, and because square root of 3 doesn't simplify, doesn't come out evenly, we're just going to leave it as is. So there are a couple of polynomial equations. Now we'll look at radicals. If you have a radical equation, you always want to get the radical alone if possible. Then use use the reciprocal power to isolate the variable. If you have 2 radicals, get one alone, square both sides, then get the other radical alone, square again. And then the one thing you do have to worry about with radical equations is checking for extraneous solutions. That is a possibility. So again, if you've printed these off, now I know that example 3 probably doesn't look like it is a radical equation. It technically is, which we'll talk a little bit about here in a moment, but basically what we're going to do is solve this algebraically. So to start, we will add the 8 over, then divide by 4, and now is where, if you come back to step 2, use the reciprocal power to isolate the variable. So what I'm going to do is take this to the 2/3 power. So when we do that, what ends up happening, the 3's cancel, the 2's cancel, And so when you have a fractional power, the top number works like a power, the bottom number works like a root. Chances are whoever you had for Algebra 2 last year discussed this issue with you. So essentially what we are going to end up making this is that this is 2 squared, so it's 2 to the seconds 4, and then we're going to take the third root of that. So for this problem, our answer is the third root of 4. You know, if you certainly try to take the third root of 4, you're going to end up with a decimal. So that's where we're just going to leave our answer as the third root of 4. So again, I know it didn't necessarily look like a radical equation, but it technically is, because when you have that fractional or rational exponent, the bottom number is technically a root. Now, for example 4, now is where we're going to have a true radical equation, where square root of 2x plus 7 minus x equals 2. Well, what we're going to do, first get the radical by itself. So add the x over. Then to get rid of the square root, we are going to square both sides. Well, the square root of 2x plus 7 squared is 2x plus 7. For x plus 2 squared, we are going to have to FOIL that out. So x squared, 2x and 2x is 4x plus 4. Then what we're going to do is get everything on one side, because usually these will factor. Occasionally you will have to maybe do quadratic, but more often than not, these do end up with problems that you can factor. So for this, what multiplies to -3 adds to 2? Well, that's going to be 3 and -1. So our solutions are -3 and +1. Now, the only thing that you do have to worry about, step 3, check for extraneous solutions. It is possible you could end up with something here that doesn't work. If I plug in the -3, well, when I plug -3 in, that's -6. So we get square root of 1 minus -3 plus 3 equals 2. Well, you can see right here, that's 1 plus 3, which does not equal 2. So the -3 is extraneous. When I plug 1 in, that's 2. Square root of 9 minus 1 equals 2. Well, when we plug the 1 in, 3 minus 1 is 2. So our only solution is 1. Radicals are one instance where you can have extraneous solutions. We looked at rationals in day 1. That's another place that you can have extraneous solutions. All right, example 5 is where, now if we look back at our steps, well, it says get the radical alone if possible. Well, unfortunately, we can't do that. So if you have 2 radicals, get one alone. I usually isolate whichever radical is the most complicated. Here, if this one has a 2x, I'm going to actually move this one over by adding it. Now, much like we did in example 4, I am going to square both sides. So the square root of 2x minus 5 squared is just 2x minus 5. That's the easy part. Much like we did up here, I'm going to write a second parenthesis and FOIL. Well, when we FOIL, 1 times 1 is 1 plus 1 times square root of x minus 3 is just the square root of x minus 3. Square root of x minus 3 times 1 gives you another one of those. And then whenever you take a square root times itself. The square root of x minus 3 times the square root of x minus 3, that's like squaring it. So that's just going to give us an x minus 3 without the radical. So from here, I am going to combine like terms. The 1 and negative 3 gives us negative 2. There's 2 radical x minus 3's, and then x. Now, from here, what we are going to do, coming back to the steps, is now we need to get the other radical alone. So in order to do that, I am going to subtract an x and add the 2. And when we do that, those cancel. 2x minus x is x, minus 3 equals 2 square root x minus 3. Now, we square again. So yes, we do get to FOIL once again. X squared minus 3x gives us minus 6x total. Negative 3 times negative 3 is positive 9. Now, over here is where you do have to be careful. 2 squared is 4, and then the square root of x minus 3, again, goes away. Now, as far as what we have from here, x squared minus 6x plus 9 equals, distribute the 4, 4x minus 12. Alright, I'm running out of room, so I'm just going to continue this over here. And now what we are going to do is move everything to one side and factor. So x squared minus 10x plus 21. What multiplies to 21 adds to negative 10. Negative 7 and negative 3. So your answers are 7 and 3. We do need to just quickly check for extraneous. I will tell you that more often than not, they will work. Usually where you are more likely to get extraneous solutions is if you have a variable outside of the radical, but we'll still plug both in. So if I plug the 7 in here, that gives us 14 minus 5, so square root of 9 minus 7 minus 3 is the square root of 4 equals 1. Well, 3 minus 2 equals 1. When I plug the 3 in, square root of 1 minus square root of 0 equals 1. So again, that's what I was saying. More often than not, it's when you have a variable outside a radical, you're likely to see extraneous. Not going to say this won't ever occur, but these did both work. So, again, like I said, day 2 a little bit shorter than what we did in day 1. But there's the second part of P7.